full braking at 100 kilometers per hour. Lock while applying full brakes along a
The formula for stopping distance is very important for everyday use. Whether you're a bike rider, a bus driver, or even a railroad engineer, this formula governs your life. Formulas affect every one of us. This is formula breakdown. Let's look at the components. D is the distance in meters, V is the velocity in meters per second of the car or object, mu is the coefficient of friction, which can be found online, and G is the acceleration force due to gravity. So with this formula, we can figure out lots of things, like how far a car will slide after braking at 100 kilometers an hour, or how far a super speed train will stop after slamming on the brakes at 360 kilometers per hour. Let's figure out how far a car will slide after it slams on the brakes at 50 kilometers per hour. So let's input what we know, and remember, the velocity is meters per second, so we have to change it from kilometers per hour, which can be easily done by dividing it by 3.6. The coefficient of friction of rubber on dry cement is 0.8. And since we live on Earth, the acceleration due to gravity is 9.81 meters per second squared. After solving for D, we found out the answer is 12.27 meters. Now let's boost the speed up to 100 kilometers per hour. Well, things get pretty crazy. Let's input everything we know, and 49.15 meters. That's almost the length of a Boeing 747. Now let's get even crazier. If it's raining outside and the roads are wet, this number even gets higher. Wet cement and rubber only have a coefficient of friction of 0.45 instead of 0.8, so let's punch that into the formula. After doing the math, you figured out that a car going 100 kilometers per hour on wet cement slides 105.7 meters after braking. That's almost the length of a football field. Now that we know how to use the equation, let's use it. How long will it take a high-speed train traveling at 360 kilometers per hour to stop? The coefficient of friction of the steel wheel onto the steel track is about 0.8. So if you punch that into the formula, you get 637.1 freaking meters. But this is all on Earth. What if we were to go to the moon? In the future, when we colonize the moon, the acceleration in the formula will be changed from 9.81 meters per second squared to 1.6 meters per second squared, which drastically increases the stopping distance. So let's bring the car back and see how long it takes him to stop on the moon. When he's traveling 110 kilometers per hour, it won't take him 49.15 meters to stop, but instead 364.7 meters to stop. And the train, it would take well over 3.9 kilometers.